All good? All good.
Great. So thank you very much for coming to this talk. I would of course like to start by thanking also the organizers for giving us the opportunity to present here today. And I also want to stress that this is the first presentation on this topic, so as you can imagine, our team, this is quite a special moment for our team. So today I'm going to be talking about an emerging project known as Control, which you can follow here on Twitter, or you can also scan this QR code to join this community on Telegram. So I'm going to be discussing a new kind of market structure that is named Gradual Order Books, and which was devised to address fairness and liquidity issues in existing market structures, be it DeFi or TradFi. Now, you can just simply think of it as trying to protect the retail user against whales and bots. Now, why might this subject be interesting for this particular audience here today? The reason is that in order to implement gradual order books on-chain and in a way that is scalable, one really needs some non-trivial functionalities. And it just so happens that these functionalities are offered by CosmWasm, but for instance, they're not offered by Solidity, right? So this is a new innovation avenue that won't be led by Ethereum devs, right? It's an opportunity for this community. And yes, let me also say that if there are two messages that I would like you to take away from this talk, this would be really that there is a new market concept in town, and second, that it's enabled by CosmWasm, right? That is the thing. Okay, so let's start. I would first like to present the team members that are present here today. We have, in case you want to discuss if you have some interest, Andreas Finke, founder, lead research and smart contract developer, Thomas Gehrmann, front-end dev, Claudia Livia, product designer, and yours truly at research and smart contract development. Okay, this is the outline. I will first discuss some fairness issues, what I mentioned at the beginning regarding existing market structures. Then I will move on to what the gradual order book notion is of control. Then I will discuss specifically why CosmWasm enables this and, for instance, not the EVM. And I will conclude with an application which is the focus of control and is prediction markets. And this will be followed by a live demo where you would be able to really interact with the prediction markets yourself. Great. So, what are the problems that control is trying to address? So, if we adopt a crypto-centered perspective, the first type of market we need to mention is AMMs, automated market makers, and then, of course, the major issue is impermanent loss, right? Your liquidity providers are at a disadvantage. Then we have the more classic structure of order books, right, which comes with a whole history of market manipulation. Then we have problems that are specific to DeFi and are common to most on-chain markets, and this is the maximum extractable value-based attacks, right, the umbrella term MEV. And then we have one issue that is common to all types of markets and implementations, and this is really front-running, the advantage that one has with bots and fastest reaction on all the rest of the market. And so let's see at what the specific advantages and disadvantages are in every case. So as I said, for AMMs, it is the liquidity providers that are disfavored, and this makes it very non-viable for big projects. Then in the case of order books, well, it's whales that are favored because you need to engage a significant amount of funding in order to manipulate the market, to artificially deform it. But it also favors bots because you need to act quickly, close your trap before the unsuspecting small fry realizes this is a trick, right? And so this is why essentially all modern market manipulations are executed by bots. Then if we look at MEV, well, then we're obviously favoring validators and again, bots because there is automation. And if we look at front running, then by definition, we are privileging the bots. And the reason why I have highlighted with all these fancy colors the word bots is because we see that one really common and central theme that arises in all this unfairness issue is really privileging speed. And so we can conclude that on-chain order book markets privilege speed over due diligence, over expertise, over honesty, and over truth, right? And then we can also say that DeFi cannot fulfill its promise of fairness while these mostly TradFi characteristics persist, right? So DeFi already addressed a specific source of unfairness that had to do with centralization. But the unfair practices that come from the market structures themselves have not been addressed yet. This has not been tackled yet. And if anything, one could argue that DeFi even added a new layer of unfairness in that respect with MEV. So, how could one tackle this problem? The idea here is these gradual order book markets. So let's get this just the basic idea, right? Think of a regular order book market. What happens is people place orders, and as soon as a match occurs, so there's a buyer, there's a seller, and they agree on a price, then the corresponding trade between the two parties is going to be executed instantaneously. So this would be represented here by this purple curve, this purple line, where you see this would be the trading volume of this exchange, and it starts from 0 and then it suddenly jumps instantaneously to some value. Now the idea of gradual order books is very simple. We're going to replace this instantaneous clearing of the trade by a gradual one in time, represented here by the green line. And in particular, we're going to adopt a decaying profile, right? You see this function 1 minus exponential, and there is a reference time, a fixed time, capital T. So essentially, if time is much smaller than this capital T, then this function is essentially 0. We're at the beginning here. And essentially, this means that at these times, the trade has not taken place yet, right? Nothing has been exchanged between the two parties. But then as soon as time becomes slightly higher than capital T, then essentially we have an exponential suppression, and we very fast reach the total volume. So at that point, the trade has effectively taken place, right? Up to an exponentially suppressed negligible amount. So okay, this is the elementary modification that we do at the level of one trade. And what is its effect at the level of the whole market, right? So the effect is that it's going to smooth the market activity over the typical timescale T that we decide. So here you can see a depiction of this effect. So the white line is going to be typically the total volume per minute, right? And you see that it's quite noisy and spiky because it reacts to every user action, right? So now if you have the exact same user actions, but in a global order book, the total volume per minute would be the blue line, right? And what you see is that essentially all the variations that take place at smaller timescales than this reference time, capital T, are averaged out. But at the same time, all the variations that happen at larger timescales are retained. So we essentially retain the information that is relevant to the retail user, right? But we take away the advantage of speed, right? Because there is no user action that can impact the market at a time smaller than capital T. So this is how we solve the advantage of speed, while giving the same experience of order book to any retail user, right, who reacts at larger times than capital T. Very good. So this was the basic idea. And once you try to figure out how are you going to make some rules for a market that implement this idea, you realize that actually you have to do extra modifications out of consistency. And the major reason is this, is that during a gradual clearing, during a gradual exchange, execution of this trade, other users are going to keep putting orders in your order book, right? So the market price, what is considered a fair price, is going to evolve while your trade is ongoing. And therefore, if you don't want to put any of the parties at a disadvantage, you have to adapt the price of this ongoing trade to the market price, right? And because you don't want to disadvantage anybody in the whole book, then it means that everybody at every single time T is trading at the same market price that we call P of T. So what has happened here? What happened is that we place orders at a given limit price, but then we lose control of the price at which we're trading, right? Because then the trade continues at market price for fairness. But of course, this is not necessarily a problem. It depends on what direction the price is going to move to, right? A buyer has no problem continuing buying at, cheaper price and cheaper price. Just as a seller will gladly continue selling at a higher price and a higher price. So therefore, we're now going to use the limit orders as a trigger price and also as a stop price, which means that, buyers will keep buying as long as the price of the market is below their limit, and sellers will keep selling as long as it's above. So this is essentially an automated dollar cost averaging system, but that is triggered with a single transaction, the one that essentially places the order. But I have really here to stress that this is not an extra feature that we offer, right? And we say an automated trading algorithm that is offered on top of some regular order book structure. This is the fundamental interaction the user has with the order book, right? Very good. Now there is only one last piece of information that is needed in order to describe this new structure, and this is how do we compute this P of T? How do we compute the market price at which everybody is continuously traded? And then to do this, we're actually leveraging some 19th century economics, which is pretty nice, right? And in particular, the following result, which says that for any order book that contains some matching orders, there always exists an equilibrium price, right? This is the price at which the total amount of buying orders that accept the price equals the total amount of selling orders that accept the price. Essentially, it's the price at which supply equals demand, okay? And this privileged price it's perfect for our purposes because it means that the total value is always conserved, right? We are matching supply and demand, so this means that value is just transferred between users, but there is no loss, no gain. And in particular, this means there is no need for external funding, there is no need for liquidity provision. In fact, every single participant is the provision of liquidity and is therefore empowered to act as a market maker. So that's another very interesting feature. And finally, the techie question, how do we actually compute this P of T, right? And this is where CosmWasm kicks in. So, CosmWasm and Gradual Order Books. So first of all, the order book information is stored in a map, CosmWasm map, that we named limits, and where the key are the limit prices of every order, and the value are all the rest of the order data, such as the amount that is placed, whether it's buy or sell, or the user's address. Then, every time a new order is placed, so at every new interaction with a market, the equilibrium price is going to change. And this is simple because you add to supply or you add to demand, so you're breaking the equilibrium, right? So it triggers a new computation of the new equilibrium price, right? So now if you add on the buy side, you want to push the price higher, right? And if you add an order on the sell side, you're going to push the price lower. So this means that we have to iterate over existing orders in that map from the old price, right, up to the maximum motion of the price that this new order can induce. And then at the level of the code, this means that we have to query our limits map, but with keys that are only in a given interval, right? Min, max being the old price and the maximum possible new price. And this will be just given in CosmWasm by the method range, right? You see it here. You have the map, you act with the method, dependencies, minimum price, maximum price, and so on. Right, so here we really you have to, I have also to mention that if you want to scale and consider large order books, right? Typically when you add just one more order, you're not going to move the price a lot. So this interval will be typically very small compared to the huge information that lies in this map limits, right? So by acting with this range method, we are returning only the relevant info that we need for our computation, right? So this is cost efficient and it allows it to scale because we will always use a very small amount of data, even if the book is huge. And this is the crucial difference with what the EVM can do. Because Solidity, of course, has also a map structure, mapping, but it carries no key ordering, which means that if you want to load data of the order book in order to do this computation, you need to load the whole order book. And this makes it already prohibitively, expensive. And also from the viewpoint just of the calculation, all this data that you have to move makes no sense. So this is why this is impossible on the AVM. And it might sound almost trivial because this is just another method for the CosmWasm crowd, but it's crucial in order to do the gradual order. And let me also add that there's another reason why it wouldn't work on EVM. It's because we have to compute this exponential function with a high enough precision, right? So we use a series expansion. And this is a lot of elementary operations per transaction. So already because of that, the cost on Ethereum would be too much, just for computing the exponential function that comes with every decay of trades. Very good. So that's it. That's the decide about what's so special, what makes CosmWasm perfect for implementing gradual order books. And now this is the last chapter. It's about the application to a specific type of market known as prediction market, and which is the focus of control. Very good. First, some background, because not everybody's aware of what prediction markets are. So, very quick. They already exist on chain, right? Contra is not the first one, so you have here some examples, but of course with the, classical market structures that I described before, not with gradual order books. They're used internally by big corporations for decision making. They're very interestingly part of the foundational motivations for Ethereum, and in particular for implementing DAO governance, and this you can read in no other place than the Ethereum white paper. They're quite funny, they predate, the AMM architecture actually was devised for prediction markets and predates by like a decade the era of blockchain. And in fact, the AMM idea for blockchain and DeFi was taken from prediction markets. As this by now famous Reddit post by Buterin clearly states, let's run on-chain decentralized exchanges the way we run prediction markets. It's there in the title, and that was the idea to use AMMs for DeFi. So now, of course, like any nice story like that, there's an irony, and it's that if you want to do an AMM prediction market, then the impermanent loss issue is going to be much more severe than for the typical uses for regular markets. So this forces somebody to do an order book for prediction markets. Let me now just discuss, this is the last slide, and then we're going to play. So this is a simple case of prediction market. Binary options. And it's the simplest because it's a future event with two possible outcomes, A and B, right? So you can think of a sports game where either team A wins or team B wins, or you can think of a presidential election where either candidate A wins or candidate B wins. Actually, some prediction markets are used for these cases. Very good. So before the event takes place, we don't know what the outcome is going to be, so the only thing one can do is attach probabilities to each outcome, right? So you have a number PA, the probability of outcome A, and number PB, probability of outcome B. They're between 0 and 1, and their sum is 1 because they're probabilities, right? But after the event took place, we know what the outcome is. So this pair of numbers is going to jump to either 1 and 0 if the outcome is A, or 0 and 1 if the outcome is B. So now the idea of prediction markets is to estimate these probabilities through a market mechanism, okay? So what we'll do is to say, let's create two tokens, A and B, and let's say that PA and PB are the prices of these tokens, okay? So here you can see in this plot, this would be the typical price chart over time of such a pair of assets, of tokens, right? So the price of A will be the green region, the price of B, the red region, and then you see that they evolve in time, but their sum is always equal to 1. So essentially you can think of it as only one independent asset. You can pick B, for instance, and then this is the price, because the price of A is always inferable. It's always 1 minus B, right? So in particular, this means that if you buy A, it's equivalent to selling B. It's exactly the same. Now, the big difference with usual markets is that now when the outcome is known, an oracle is going to feed this to the contract, and the price will jump to either 1 or 0, depending on what the outcome is, right? So this is very different than usual markets because there is an external action that affects the price, right? And so then it's simple. If you bought A tokens, right, then you bought them when the price was less than 1 before the outcome, and then if the outcome was A, then you made a profit. But then if the outcome was B, then you lost your money, right? So this is essentially betting, right? You've transformed this into betting. But it's more than that, because it's betting with a market structure and dynamics, okay? So that's the subtlety here. It's that when you buy A, for instance, the price increases, it's a market dynamics, or when you sell it, it decreases. And this means that the price PA, right, is an evolving estimate of the market, of what the probability is by the market, right? And so this is quite different than the usual betting venue where you have some preset odds, you put your money and you just wait to know if you win or if you lose. Here, instead, you have publicly available, right, evolving odds that always describe what is the market sentiment, and you can react on them live, right? So this is something quite special, and this is why prediction markets are ultimately used as information aggregators, right, in order to make decisions. You could say, in a sense, that they are a continuous survey of evolving opinions, right? So they leverage this so-called wisdom of the crowds, but they also force people to put their money where their mouth is. So this is an extra quality, let's say, not necessarily assurance, but this is an extra, this incentivizes, in a sense, expertise and due diligence. It's not any just survey without any risk for the participant, right? And because it incentivizes, you know, as I said, due diligence and expertise, this brings us back, this closes the loop, it brings us back to the fairness issues I was discussing at the beginning. Because we know that the usual order books, they don't privilege expertise or due diligence. They favor speed, that's it. It's the fastest who wins, right? And in this case, in the case of prediction markets in particular, front running, for instance, is particularly devastating. So if you take again the example of, take a front running example of the presidential election, imagine at some point there is a huge scandal that destroys the chances of candidate B, right? So the first bot that is going to react on this and buy massively A tokens has just wrecked the rest of the market, right? So prediction markets are particularly vulnerable to this kind of speed-related attacks. I mean, or exploits, however you want to call it. So this is the number one roadblock, right, to large-scale adoption and use of prediction markets. And gradual order books simply remove that roadblock. Very good. Enough said. Time for a demo. This is the real deal on Terra Testnet, right? So this is implemented. This is on blockchain. So if you scan the QR code here, you'll be redirected to the mobile app, which has some limited functionality because it was really built in 2 days for the purpose of this demo. And then it's very simple. You don't need any wallets or already, you know, loading wallets with funds. It generates automatically a seed phrase. It airdrops Luna. You're ready to play. On the other hand, if you want, you can follow me. I will soon switch to the web app, the alpha web app.